optimization. I think this is our third one. We're going to do some shapes and, like, I don't know, maybe a square and a circle and talk about areas or maximize a triangle and a hexagon or I don't know. I don't know if that makes any sense anyway. But shapes inside of shapes, just doing some silly shit here and let's get after it. Steps to solve. We've seen those and then here's our problem. All right. Very simple, short to the point. We want to find the dimensions of the rectangle of largest area that can be inscribed in a circle of radius 4. Part 1, don't panic ever. Don't panic. Don't panic until after, at least after you make your picture, and then you still have no freaking clue. But at least make the damn picture first. So step 1, find the dimensions. So we're trying to find dimensions, by the way. We're not trying to find any areas of the rectangle. Find the dimensions of the rectangle. Should probably get the equation right now. Of largest area that can be inscribed in a circle of radius 4. So the circle of radius 4 inscribed in. I don't think you need to know what inscribed even means to really get what this is, but now you kind of have it. Inscribed means would be touching, so we'll draw it in like this. Got some sort of circle, or whatever the heck I just made. You know what? I have technology. Why don't I freaking ever use it? I just don't. Yeah, look, that might actually look like what I'm trying to do. Possibly, know what I mean? But now I'm going to draw more shit. It's not going to look right anyway. So we're going to say we're going to put we want to find the dimensions of the rectangle of largest area. So let me just draw some sort of rectangle. Inscribed. Of course, not the scale, right? So it's where it's touching right like this. That would be inscribed in there. So neat. I'm drawing a picture, but wait a second. There's got to be more information than just this. Find the dimensions of the rectangle of largest area that can be inscribed in a circle of radius 4. Oh, so the radius of the circle is 4. So should I go for the radius and draw like this? Should I take it and go like this? Oh, maybe should I take it and go like this? You haven't started to catch it. I like triangles. A lot of these problems can be handled with just simple Pythagorean identities. Simple shit like this. So this is 4, correct? And if we were to continue on and go to here, wouldn't that be 4 more? Y'all know what 4 plus 4 is? Of course you do. Huh, so we know the length of the hypotenuse. Is that the hypotenuse of a triangle? Of 2 triangles that we have sitting there facing each other? Do you mind if we just start giving it some letters? Like maybe call this the, I don't know, you want to call this the length? You want to call this one the width, maybe? You want to call one X and call one Y? I kind of like X's and Y's. I'm going to go with X and Y. You know what I mean? Call one X, call one Y. Or, because this is Y and then this is X as well. We don't need to write all that shit in there, do we? Okay. So let's take that triangle out of there. And we'll kind of take a look at what we got going on. All right, so sometimes you want to write 2 of them. So taking the triangle out, just one of them, right? And you have X and you have Y. And then you have a hypotenuse of 8. That's one of those triangles. But what we're doing there is we're trying to find some relation between X and Y. And I'm kind of jumping the gun. We drew the picture. I should try and write down the equation and then notice that we're missing it. But I just couldn't help myself here. So we'll see why I'm kind of, what comes next and why that's going to be so necessary to know the Pythagorean theorem through this. Of course, you know the Pythagorean, but using it. Our second step is we want to find ourselves an equation. And since the question is asking for find the dimensions of a rectangle of largest area, that's telling you you're using the area formula for a rectangle. And we all know what the area formula for a rectangle is. That is only going to be that area is equal to base times height, or it's going to be, or of a rectangle is going to be base times height, x times y for what we're using. And there's our equation. Now we need to come up with our constraint, and our constraint's going to come right from here. Our x and our y, some sort of relationship between that so we can sub on in. So we have the idea that x squared plus y squared is equal to 8 squared from right down here by using our Pythagorean theorem. So here it is. We have our constraint. Cool. We got a constraint. We have our equation. Now we don't even need to look back at that problem again just to figure out how to answer the questions. We can just go solve everything with math. So us math people, like me, I'm excited. Let's go. We got through all the other nonsense. Now we just have a system of equations. It's a game hopefully you got to play in college algebra by plugging in where it's not just having it to where it's all linear systems of equations, but things where there's multiplications and squares makes it a little bit more fun. But I actually do need to refer back because we have to do something to solve for x or y. All right, so let's say we're going to go solve for x in terms of y. We subtract over the y. Now we're going to hit it with a square root. Now typically, don't we need to be mindful of the plus or the minus? We absolutely do. But in the context of a problem with a length, do you think a negative length makes any sense? Absolutely not. So let's get right back to it. Let's get rid of that nonsense. We don't even need to think about it. So we've done a substitution, right? This is our third step right through here, trying to find some sort of sub that we can take and plug on in up here for our step 4, where we're going to take that, plug it in, and we're going to take the derivative and set it equal to 0. So a is equal to y. And there it is. We just plugged it in. Instead of writing x up from up above, this x from up above, we just wrote what x is equal to. Cool. Now let's take this and pop it up and let's do a little bit of work to it. Let's clean it up first, of course. Now, how do you want to do this? Do you want to do this as some sort of product, or do you want to use this concept that y is just equal to the square root of y squared? Just because for that y I said before, we didn't need to hit it with a plus or a minus. A length can't be negative. And that's the only reason this is true. Because typically, if there was no context to this problem, this is actually just equal to the absolute value of y. But since we know it's positive, since we're dealing with lengths, we can do it. And why the heck is he doing this? Well, I'm doing it if you could just bring it inside and call it 64y squared minus y to the 4th. That's just a choice. You don't have to do it that way. You could have done it any way you want. And I'm even going to change this a step further. That's a square root. Let's write it to the 1/2 power. Shit, now we're ready to go. Let's hit the shit with the derivative. Both sides. Let's go. The derivative with respect to y. All right, here we go. And we're going to set that equal to 0 in a second. So let's do our little our chain here. The 1/2 is going to fall to the front. Or you always leave that interior alone. Don't touch that till once you're done writing. Oh, don't forget to subtract the, hey, there's that game, times. And now we're going to want to take a derivative of the interior. Now it's time to mess around with that thing. So that's going to be, what's that, 128y minus 4y cubed. Bang, we got it. Now we're going to set this thing equal to 0. And hopefully I can teach you a fun little trick right now. You notice this negative 1/2 power right there? Do you know what that means? That means it has nothing to do. It has nothing to do with equaling 0. It has nothing to do with equaling 0. Why? Because that means that needs to go down to the denominator. This needs to be in the denominator down with the 2. That's 64y squared minus y to the 4th, raised to the 1/2 power. Or you could wrote that with a square root on it. Set equal to 0. Only the numerator makes something equal 0. Therefore, we have 0 is equal to 128y minus 4y cubed. Let's go solve this. A little bit of algebra. Fun with algebra. So let's factor out that 4. I'm guessing a 4 is going to be able to pop out of there. What's 128 divided by 4? Anybody got that one? Anybody got my back on this? What's that, 74? What is that again? 64, 32? Oh, there it is. All right. I'm slow tonight. Minus, let's take the y. And we get y squared. There we have it. So, well, we have it all set up there. Let's do this. 0 product principal. Set 4y equal to 0. Of course, the 4 doesn't make any difference. You get rid of it. So y equals 0 is a possibility. or 32 minus y squared equals 0 is a possibility. Now, can you figure out which one's going to give you the minimum and which one's going to give you the maximum? Any guesses? Maybe it's going to be the one that's 0, where y is equal to absolutely freaking nothing. And we're trying to find the largest area. So do you mind if we just kind of cross this one out going your nonsense? Cool, and we can just solve for the other y. So we have 32 is equal to y squared. And y is equal to the square root of 32. We could break that thing down, right? Isn't that this is 4 root 2. We found it, but let's wait to figure out what the heck the question's asking us. So we're really stoked on ourselves. We found our y value. We could absolutely go plug right back in and go get our x value. It's asking us for dimensions. And it's asking us, find the dimensions. Oh, 6. So that's just asking, go find the width. Go find that x value. Now, we must have something that tells us. We must have something somewhere that tells us. And it's going to be that substitution. Wherever that substitution is where you want to plug that sucker right back into. So let's use this idea from part 3. That we have our y is equal to the square root of 32. So right over here, we also have x is equal to the square root of 64 minus y squared. And from our problem right here, we have that y is equal to the square root of 32. So we plug it in, and we got these two things dialed. It's done. Look how simple this is going to be to pop in. Square root of 64 minus, what's the square root of 32 squared? Anybody know that one? Isn't that going to be 32, which is equal to the square root of 32? So x and y are both equal to the square. X is equal to y is equal to 4 root 2? So you mean it's a square? So a square typically yields it will yield the largest area when it comes to a rectangle. Well, our one example is a little bit different because we had it wasn't an actual square, it was only 3 sides. Typically a square is going to turn out to be the largest area you're going to find out of a rectangle. We were in a class to do a whole big thing on it, but I want to completely bore you. So we finish this thing up, we look and find the dimensions in the circle of radius 4. I don't give any sort of units, therefore I think we have solved it. So we go boom, both our x and our y would be 4 root 2 units, and that would be it. It would be a square. So I will see you on the next one.